Hi everyone, very good evening. I hope I'm audible perfectly, right? Can you please acknowledge that? Can you please acknowledge that? I hope I'm audible perfectly, right? Okay, that's very good to know about it. Okay, yes. So I can see some of the particular chat, okay, regarding it was 7 o'clock or 8 p.m. Okay, somewhat like that. So it is all being oriented with that, right? Okay, it is obviously 8:15, the time of the boot camp. Uh, priorly it was like, okay, the one day it was like kind of 7 o'clock, but obviously the timing is 8:15. So can I get to know if any questions, any doubts are being there to anyone? Any sort of doubts to anyone into the two of the boot camps? Okay, the session boot camps. Okay, do we have any questions to anyone? I can see your doubts. The live class was scheduled to this and haven't got live, and it's showing it's live at. No, it was live at 8:15 only. Farhim Aftab, right? A very good evening to all. A very good evening. Okay, that's very good to know about it. Okay, so let's just start with today's agenda. Let's just begin with it. Okay, and see what exactly we are being moving forward. If you remember, I'll show you the code of like day 2, and to be honest, if I'll say these codes and everything, it's already being there with you. Okay, so now if you will be seeing yesterday's YouTube live, okay, there would be one link that's been pinned. Okay, that's basically all comprising it of for day 2, an entire Google collab only. Okay, so this is an entire Google collab link is already I've just given because it is the entire project has been integrated. Okay, and let me just tell you one thing more. Make sure, obviously, be continue with now the remaining sessions today, tomorrow, and day after tomorrow. We are gonna integrate our project also. Okay, I'll show you how do we integrate this thing. Okay, within website. Okay, how do you see the live integration of the websites and everything? Okay, I'll show. And there would be one thing, one tool you will be learning. It's in Cursor AI. Okay, we will be making one sort of a websites. Okay, to resolve it, and it is all comprising of it, right? Okay, it is all being comprising of it, and it will let you know that okay, what all the things you have been doing it so far. Okay, right? Okay, good to go with it. Oh, very good to go with that. Okay, it should be included, okay, inside it. Now, uh, as per the T4, we will be connecting it. So we will run every step once again, and as I've told you, like okay, you don't need to write it step 2, okay, for the manual way. It is automatically like okay, it is gonna be getting connected. Okay, um depends upon you whether you wanted to rewrite your codes again and again, but I don't think so. It is just like uh is it like okay, really needed and all? Like it is not basically, right? Okay, let the steps and all, let it get performed properly. Step number 2 and 3, this sheet probably you have with you, but those who have joined late, guys, please be continue, stay from like okay, beginning to the end, the moment like okay, your class is being wrap up or anything like that. Okay, because now if you miss even a single line, okay, of the code, okay, it's gonna be very much difficult for you. Just open the chat section, you will see that one link is being there. This link is basically for this Google collab. Okay, this is for the Google collab, and you will probably able to see it. Okay, this is probably you will be able to see it. each line of code, each line of like, okay, whatever we are running, it's not being given an access to you for the editor mode, but it's, yes, probably it's been given an access for you into the viewer mode. A very good evening. A very good evening. Okay, step number 7, step number 8. This was the day 2 exploratory. Okay, there was the graphs and everything, the venue, yearly, team funding. Okay, and all. So today we have a day 3. Okay. Okay, what is a day 3 actually? We wanted to start. It's a very it's a very kind of unique ways and everything it's being there. Now, what does it mean? What does it basically have? Anyway, any code has been missed out. The link of the Google Colab is already there with you, and at the last day and tomorrow, okay, tomorrow obviously it's not a last day, but tomorrow I will be showing you how do we implement the ML, this entire ML code also with some sort of websites, okay, to see the outcomes and everything, right? Okay, I'll show you a very pretty good way, okay, that's being required. So at the day 3 we are gonna do about the feature engineering, okay, and the model building. Okay, so the concept comes okay over here for the model building and the uh, feature engineering. How do we create the new features? Like, we wanted to create what? We wanted to create that even though if something, okay, which is being helpful to us, okay, even though the things, okay, which is being there to represent it, we wanted to just start, okay. um Over here, obviously it's in prediction, okay, it's in prediction of it, and in the line by line the code you will be understanding towards how you have related in the 2 days. Now we already have the overall goal for this is like what we wanted to create a new features by improving the prediction. So very first type of goal, okay, I have, okay, or I need to make like this. Number 1, okay, the first goal is, okay, the number first goal of this is we wanted to create the new features that can be improved the prediction. Now let's say today I make a prediction tomorrow that CSK is gonna win, okay, between MI and CSK, right? Okay. But although I can see the practice, okay, although I can see like a lot of factors and everything, that I don't think so like this team is even gonna win, okay, by like, okay, the second half of my thinking would change, like I don't think so the CSK is gonna work, okay, I think MI is gonna be pretty good. So this is, I am just changing the new features, okay, I am just going to get it some sort of new it could be your ball wickets and so things, right? Okay. Secondly, it comes about how do you train the multiple machine at the one go. Okay, or you can say improve the machine learning model or model to predict the winner of the match. Okay, now obviously between two teams, any one of that could be possibly it's being there that any one team is gonna win, or there could be like, okay, abundant method is also being there that no team is gonna be approved by, right? Okay, then secondly is comparing their performances, okay, comparing their performances and everything. Now step is pretty good, like I've told you that you don't need to write uh, again and again, or you don't need to import the data set again and again. If you wanted, you that's your benefit, okay, but if you don't want it, okay, you don't need to, because again and again already at the once you have run your data set. Why there is no need, okay, to go with it. Guys, one question is there, to you all. Are we all getting the things clearly? Are we all getting the things clearly? Can you say yes or no at least? Are we all getting the things clearly? I hope there is no doubt for what you have done it so far, or like, okay, what you are doing it so far. Come on, let me know. If yes, you can probably ask me, okay? I can repeat it the number of time you will be saying to me. Okay, I can repeat it according to that way. But do not keep any sort of like, okay, the questions in your mind, okay? Because that's gonna be your loss, even, I would say. Okay, that's probably your loss then, right? Okay, got it. Now the point comes, okay, over here is, okay, the point comes over here is what is a feature engineering, right? Okay, and what is a model building and how do we do it? Okay, and so things, correct? A pretty good definition is being there. Whenever we talk about the feature engineering, okay, we always say it's a kind of a process of creating, transforming, selecting the inputs, right? Okay, so whatever inputs could be there, or you can say variable inputs, and this variable inputs is known as feature. This variables is being known as features, and that can help you out to make a better predictions, right? Okay, in a simplest way, it's how we prepare our raw data so that model can understand it. Now if I'll start talking in a French, okay, or Spanish, or any other language, you people will not be comfortable with it. Okay, I am very sure about it. Like, okay, you people will not be comfortable. Now what in what way you will be comfortable into is when we have a common language, right? Okay, English, everyone is going to understand it, right? Okay, every single person is able to understand the English and all, right? Okay, no other person is being there who is not gonna understand this particular English and all, right? Okay, might be difficulty to understand a bit, but not that much, okay, not that much into it. But if I'll start talking about the French, okay, I'll start teaching about like, okay, into the French language and all, okay, you will feel like, okay, what she's been talking about, it's just like, okay, getting over our head, okay, and all. We are not liking it, and so questions would be there. But when I just take a common kind of a language to communicate with you, and the platform we have is the YouTube, okay, and we are being getting it fit to the environment we wanted to just adjust for, right? And this is what we get to know that, okay, the feature engineering is, okay, where every predictions is being getting it fit towards what is being logically being made for, right? So machine learning model does not understand the raw data, okay, they does not understand any kind of a raw data what you are being talking about. Okay, the categories are being there is three categories. One is numerical, meaningful, and structured inputs. So the quality of the feature depends how accurately, like, okay, the model is going to get fed. A very good saying is being there in data science, actually. A lot of authors used to say it: better features make better models, not necessarily more complex algorithm. That means anything could be like, okay, good to go with it with the good models and all. It does not matter how simple or complex the algorithm we are using it, okay. It's insane into like, okay, the data science, actually. Okay, now what it happens is, okay, over here is, we wanted to go with the top batsman, we wanted to go with the like top bowler wickets, okay, who are being taken, and so things. Okay, now similarly, if I'll say that what is a model building, okay, uh, it is the process of training a machine learning algorithm, okay, on your particular data set, whatever the data set you're using. Aries dataset, Wine dataset, okay. You have Titanic dataset, breast cancer dataset. A lot of datasets are being there. IPL dataset, okay, a lot of dataset. So whatever the processing it's been happening and training is being getting it processed with it, okay, the model itself is gonna learn, okay. Now robots does not being there, okay, just like normal way. Robots are being made, they are being trained actually, okay, in a certain amount of time period. Don't you think, like, okay, if I'm training this phone, okay, let's say if I'm training this phone and all, I wanted this phone to learn from me. Okay, the phone does not understand my language. I have to train it, okay, into the bytes, binary bytes, okay, and all, into the language and all. So I'm putting something into the particular object. I'm training that particular chip. I'm training that particular model to run it into the accuracy particular way, right? Okay, so it can learn the pattern. It can make the prediction of the or unseen about the datas and everything. And there we go with the features and the outputs of it. Normally I will be writing it x, that's basically features, okay, and we have small y, that's basically your targets. Okay, so x, when we talk about x, that is basically input, and when we talk about targets, that is basically prediction. Okay, and all of them maintains into the different orientation. Okay, any sort of orientations and everything would be there, okay, and it does not matter for what kind of a logics you're maintaining it, okay, for what kind of, okay, the proprietarial logics, okay, you're gonna make it, and it is just normal also. Sometimes, like, okay, it feels like, okay, or it attains like, okay, uh, that it's in simplest into the order, but sometimes it feels like, okay, it is not, okay. So depends basically how does it orientate, okay, how does it looks like, okay, how does, like, okay, it starts at the best recognizations, right? So this is what, how you represent the model. This is how you, like, okay, you just try to figure it out with the different kind of model, working with the models and everything. Okay, depends upon what is the features and what is the targets, okay, depends upon what is, like, okay, and how does it is being representing into the what source of order we wanted to start with it, right? Okay, and yes, I guess, like, okay, basically that is what we need, okay, this is what, like, okay, we just wanted to just get it in sure also, correct? So yes, I guess, like, okay, we can start with the code now, uh, recognizing this. Okay, no questions, right, till here? Okay, no need to run the dataset again and again. Already the dataset has been run of that particular orientations. Okay, no need to run it. Okay, overall goal is that only, comparing the performances, training the multiple kind of learning models. Winners could be there, bowlers could be there, batsman, okay, and all. I've already read the data from the Kaggle. Two methods I've told you. One is like directly from the uploading. Another one is copy pasting the link from the Kaggle and then running it. A process which is being given to you as an of the new meaning full dot seed, that's 42, right? Okay, now it will say where is NP, right? Okay, obviously at the very starting, if you say we haven't imported numpy, I guess, let's just check it out. Yes, so numpy is not there. So what we can do it is, we can simply write it one command, import numpy as an np. The moment you will just import this, okay, this is a step to perform. Okay, step number one, uh, which is being there as one of the feature engineering. Okay, import numpy as an np dot this is going to represent as an of the seed, and this is random seed is going to ensure the reproducibility, where 42 okay, ensures that uh, every time, okay, we run this code, okay, we get the same random number of the outputs, okay. So we need to create the features, we need to create the top batsman runs and everything. So we will probably going to write it like this: df top batsman okay, underscore run, okay, is equals to np dot random dot randint, okay, we'll specify 2080 size, okay, and the length, the df it's being there, right? So this line basically meant of that we are being adding a new column, okay. Whenever we wanted to write it 20 to the 80 of the each row, we wanted to just start with, we obviously there is no column, okay, there is no nothing as one of the column is being there, okay, or anything like that. We are adding a new column that's in top batsman run. Now when we add upon the top batsman run, okay, and all, from where we are gonna get the data, right? The question is from where we are just gonna get the data. So data we wanted to get it from the, as we are gonna make a dummy data, okay. What we are just gonna do it is we are just gonna make a dummy data and everything, stimulating like, okay, how many runs are being there as in top batsman, and it is going to be scored by the each team into the matches, right? Okay, and size is equals to length df ensures one value per row, okay. So you can just run this, one value per row it is going to be there. The moment you do that, okay, the moment, okay, you just do that, okay, or anything like that, okay, let's say, or we can create write it, create a new feature, okay, which is being there for the top batsman, okay. Then we wanted to create another feature that's top bowler wickets. So feature engineering is this only, you are creating a new feature, you are adding the dummy data and everything, and that's done. So now you will be creating another feature, okay, that's gonna be there, that's the top bowler wickets, right? Into the top bowlers wickets it's being there, so we will be writing a df sort of top bowlers is equals to there, and it's in wickets np dot random dot randomint, and we will specify the orientation, let it be 0 comma 3, and obviously then we have the size is equals to length df, okay, that's being there. Adding a new column top bowler wickets representing the top bowler wickets into the particular matches, and the random int teaches between 0 to 2, okay, which could be a possibility like, okay, we can get it from 0 comma 1 comma 2, okay, and again it's gonna be the fake data, okay, for just a demo. We don't have, okay, we were not gonna collect, okay, the data for it, okay, who are the top bowlers and wickets and all, okay. We are creating a fake data for it, okay, that really mimics the real match of the states, right? I hope that's clear. Any question in any kind of like, okay, syntaxes or anywhere, you can let me know if you have anything, okay. I'll clear it right now. Anywhere you feel like, okay, ma'am, I think I'm not understanding this particular syntax, I'll help you out, don't worry. Let me know please. Anywhere you think like, okay, ma'am, I'm not understanding this and that syntaxes, can you please repeat it? I am gonna repeat that, don't worry about it. So we all over here are being there, okay, just to sort the things out, just to carry forward with it. Let me know please, everyone. Come on everyone. No questions? Okay, then let's start with it. No problem, no problem. Now what's next about it, right? Okay, into it. Now obviously we created for the top bowler of the wickets also. Now we will be creating a feature that is team form, okay. Now for what reasons we have been creating, okay, what exactly the feature we are creating, a newest one as creating the team form. So we will just simply write it You can't predict the future. Actually, I cannot. Okay, to be honest, if I'll say, if that tool has been there, I could have done. Okay, but I cannot predict the future. That's probably not into my so and so hands, right? So create features, that's basically there as of the team form. So DF, uh, when we talk about DF, okay, I wanted to just start with a team form np dot random dot randomant. Okay, 40 comma 80. Okay, size is equals to length df. Okay, creating a feature again, team form. It will measures how many team has been performed recently, giving values between 40 and comma 80 and all. Okay, represent how does like indexing of the average recent scores are being available or being provided, right? Now the moment you wanted to display the first few rows, so what we're gonna write it as display the first few rows. What is np random seed? Okay, Janti, what is an np random seed as being there? As I've told you, np is numpy obviously, and random seed is it will set a random seed so that the results are being reproducibility. Now if we don't, if we know like okay the top ballers are being like so and so, okay, let's say in 2022 there is an xyz top baller. Okay, in 2021 there was an xyz baller. Okay, same the reputation has been coming. Don't you think like okay if I have to call it all the thing and I have to write it everything, instead of that I could have been given that this person is being there in so and so years he performed really well. Okay, and what is a 42 is every time we run the code to get the same random numbers. Okay, same amount of random numbers we have. So this is what np.random.seed, okay, 42 does it mean. Okay, every time we wanted to follow the conditions. Okay, now we will be just printing the first few rows and we are going to write it print df dot head, and if you see these are the betting team, bowling team, better ball, okay, bowler wickets, okay, betting partners, okay, and everything, top bowler wickets, top batsman, team form, these all of the columns you have randomly added. Okay, just now you've created a feature, okay, for it. So it does not mean like okay, or it does not make a sense like okay from where does it comes. No, it makes a sense like okay it has to come no matter what. It has to come, and okay, because it is there into the column, right? Okay, it is being there into the columns and everything. We cannot ignore it. Okay, we cannot just try to write it okay, exemptly over here, right? So now after all, once you have printed like okay or displayed the very first few rows, okay, you have to virtually confirm it with the new features were added upon, right? Okay, now after all, step number 3 splits the data into the features, that is x, and target, that is y. Y is small, okay, not capital. Capital, do not write it because it will have the different kind of syntaxes, and whenever like okay different kind of syntaxes are being there, it has to relate it, and whatever the relations are going to come, you would need to address that out. Okay, so x as a feature, so you're gonna write it x is equals to df dot drop, okay, winner, x is equals to 1. This is a feature, and then we have a variable that df winner. So simply just write it this way, that okay batter and bowlers and so things. So you need to address that. Okay, so the moment you will write it, okay, it will, I think toss winner would be there, right? Okay, winner ultimately like prior to the cell also winner was not working, so now we have a ultimately this particular sort of values. Okay, Okay, match won by or the toss winners. Okay, all of that you can put. So this is just splitting. X is all the columns except the match won by. These are the our input features, and Y is match won by. Again, that's basically target variable. The things we wanted to predict. Okay, for the further agendas, correct. So whatever the further agendas are being there, whatever the conditional agendas are being there, it will just ensure that okay how probably you're writing it again, what you're being creating it for, so and so things, right? Okay, so this was just to split the data into the features and the targets X and Y, right? Then it comes toward the next thing is training and testing. Step number, I guess, 4. Train and test the splits. Okay, train and test the splits. Can you let me know what is our training and splitting, training and testing and all? Can you let me know? Anyone? It's being so long now. Okay. Can you let me know what is it? Okay, I'm just looking forward. At least one of you will be responding back. What is the training and the testing? Come on, come on, come on, guys. Okay, I will tell you. Uh, the ways you need to just start. Okay, so I have an answer from the Bishwajit. Okay, let me just get ahead. Before creating a model, we separate the data that performs onto the ML model to check the accuracy of the model. Very good. Yes, correct. Perfect. More answers, please. More answers. I'm just looking forward to get onto these kinds of messages. Okay. More answer by Bishwajit actually. After training, we check the model. I think same, right? Okay, not a problem. Okay. So yes, that's correct. Okay, whatever the unseen, based on to any kind of an unseen data and everything, or the testing of the data, we wanted to just get an address for. We look forward. Okay, we look forward to go with that. Okay, and every single thing. Okay, it is not only that okay you will get it onto your certain sort of plateaus and all. No, you need to just grab that. Okay, you need to just get onto this particular way, that okay how exactly you wanted to just start. Okay, uh, to provide before the model training. So we will just write it from sklearn. Okay, dot model selection import test and train, or train or test. What I've written is I have written this x underscore train, x underscore test, y underscore train, and y underscore test. So one is the feature and another one is being the targets. Okay, both of them would be there. The method we have applied is train test and splits. Okay, x comma y, and there is a test splits, that's 0.2. What is a 0.2 actually? 0.2 is 20% of the data is already being tested, right? Okay, 20% of the data is already being tested. Okay, so I have from the Naveen also the answer is there to filter that data. Very good. Okay, Bishwajit, it's necessary to create a new column top. See, it's not that way. Only if let's say later on any column you wanted to add, which you wanted, like, okay, your data, dummy data should be there. Okay, so you should know about it, like, okay, how to create the raw, okay, or the column, how to add that upon, and how to mimic the data. Okay, but let's say in any case, my column, which is the top ballers, now I wanted the low. I just need, okay, the compare, as I've already have the top ballers, but I need, okay, I should have uh, the low rated bowlers also. I could write it, okay, the low rated bowlers and everything, correct? And for that reasons, okay, I'm just adding one column so that I can compare it. I know the data is not gonna be the accurate for the low rated bowlers and all, because it's just a random data, okay, the dummy data is being there. But anyhow, later on I can remove it also, the row plus column both. Okay, or even those individual of it, I can just delete the column also, I can delete the, okay, the row also. So does not matter onto it, okay, does not matter. Correct, Vishwajit? I hope your query has been clear. If you wanted to import the machine learning, simple machine learning models. Okay, so certainly the model we will be going with is the linear model, and you're gonna import the logistic regression, random forest classifiers, XGBC classifier, or XGB classifier, and instead of SVC, you can go for accuracy score. Okay, so you can probably write it, okay, from sklearn dot matrix import accuracy score. Okay, and you can run it, right? So we have to import the three different basically ML model. One of them is the logistic regression. Okay, and into the logistic regression, it's way more simple. Into the classification model, it is not that difficult what has been compared for. And when we talk about the random forest, it is an ensemble of the decision tree. If you see a tree, okay, how does a tree has been compared, okay, what all the things are being there, and what all the logics of the trees is being compared as, just from the root, okay, a smallest kind of uh, I would say the trunk, or you can say a branch comes, right? Okay, when from the root, okay, there's some sort of the branches comes and everything, or the some sort of, like, okay, simple branch comes, and then as it grows and all, it spreads, correct? Okay, it spreads and everything, and then it becomes a trunk also. It basically gives you, like, okay, the branches with the leaves, okay, and all the fruits. So the moment you just trim or that particular sort of, like, okay, you can say the plant, okay, it outgrows, okay, more lush green, correct? Okay, more greenery effects are being there, and good kind of a fruits, the flowers and everything, it outgrows, correct? So this is what basically the decision tree classifier is also being there. Random forest classifier, decision tree classifiers, okay, it will just outshine better when you write it into the foremost way. Okay, it will just go with an I would say a pretty good way. If you have some logical outspoken way, okay, if you have somewhat, like, okay, the different matrix about it. So random forest, decision trees, okay, it shows like that. And what is an XGBoost? Either you can write it into the capital way, or anyway, it makes a sense, right? Okay, it's a very powerful gradient kind of the boosting algorithms. It is also way more competitive to other algorithms. XGBoost is the brain of, like, okay, entire models. Okay, the algorithm is being there, XGBoost and everything, also known as XG means, okay, that's an extreme. Okay, X means extreme gradient boosting. So it's a very powerful and the popular open source machine learning. uh, it depends upon how does, like, okay, where exactly the ensemble would be making it the weak prediction models, typically into the decision tree, but it's way more sequential into the order, focusing morely onto objective functions. And what is an objective function? As an of the tree, when I talk about the tree, okay, in a tree there is a lot of losses are being there, depending upon the weather condition, depending upon erosion, soil erosions and everything, right? Okay, depending upon the windy conditions and everything, right? Okay, so a lot of losses are being there. Let's say if I talk about apples, correct? Okay, previous year if I'll say, like, okay, I'm assuming, okay, previous year if I'll say I got it 100 kgs of apples, okay, from one tree, um does not make sense even, okay, sometimes, but still, like, okay, but this year, okay, I'll only get like 20 kgs or 30 kgs and all. So that makes what, okay, the previous year the conditions and everything was pretty good. It was so kind of an oriented way of it. And might be this year, I would say this is not even like insured about it. So there is a lot of losses are being there, like weak predictions as being there, loss of entropy as being there, L1 L2 regularization, that makes a sense. For regularization, which is going to penalize the complex models, which prevents the overfitting. Okay, unseen data, that is an overfitting, right? Okay, so this is basically required. So you need to import that. You need to import all these three things, okay, with the accuracy score, the prediction, where it exactly makes a logic behind. Right now, it comes step number 6. Training and evaluating the model, right? So with the help of logistic regression, with the help of random forest classifiers, with an XGBoost and all, okay, we will make the training and the evaluation of the models. So very firstly, I'll be writing it LR is equals to logistic regression. Okay, max iteration, I can go with my max iter. Okay, I can go with this 1000. Okay, lr dot fed x underscore train comma y underscore train, print any message you can write it, logistic regression accuracy. Okay, just check where is an issue, I guess. Max iter, okay, double equals 2's are being there. Okay, so I'll be calculating the accuracy score, y underscore test lr dot predict x test and everything. Okay, so it will be just normal, right? Okay, it will just prevent onto the things like, okay, how do we exactly going to write it? So logistic regressions and everything, syntax comma. Okay, got it. So yes, there is an issue with this particular line. After this comma is required, cannot convert. I think it could convert it only. Okay, no problem. So what other things, okay, we can do it is, if it cannot convert to the particular string, max iter, we use it for only if, what is an lr? First of all, lr is your logistic regression, so there is an issue into this line, step number 3. Obviously that was a date, we haven't recognized it. Okay, now if you just go down, it will run. Okay, does not matter with the date actually. Let's see. LR is logistic regression and max iter is how many times the algorithm will run through the coverage. Okay, okay, for any kind of in coverages and everything, it will run it properly. So it does not matter. Could not convert the string, so we can convert it with the help of this. Convert this and check the code. Okay, because it is following from the day 1 and day 2 both, so you need also to follow that all. Okay, It has to follow everything from the beginning. Okay. You have dropped the date column because there is an. Yeah, I got it. I guess. But does not make sense even. Like, okay. We can just try to write it a value issue. Okay. Because we have dropped, okay, the date issues. Correct, Vishwajit. So let it convert it. Okay, does not matter. I just wanted, okay, over here the feature to run it. Obviously, I don't have included any sort of dates and everything. Okay, so we could change it. Okay, change this code. Okay, I'll write it. Wait, change it according to the above source of codes and make it matching with the columns. Okay, somewhat like that. So it does not matter. Okay, don't worry. See, winners are not being getting it done. So winners like, okay, I've already been removed. Okay, so now it does not make so sense. Like if again and again I'll write it the winners only, right? Okay. Even though if I don't need it, so why would I'll write the winners and all, right? So change it accordingly. So it is also being saying it changing accordingly, right? Okay, before you pursue that. Correct. Clear? Any questions till now? So we can just change it according to what is being required and how it exactly it's being required. Chalo. So it will just change it according to its own steps. We don't need to do it anything. Okay, we don't need to do it anything. So what I'll do it as again, uh, we can run it the separate kind of the codes. That's basically label encodings and so and so. Tomorrow when we will run all the cell, tomorrow when we will be running all the kind of a cells and everything, you will notice that these errors what you're getting it now, it won't be there. Okay, it won't be there because there is a reason behind it is it will exactly get changed because of the logistic regressions and all. I'll write it this code, okay, for the random forest and all, but we won't be running it because tomorrow I'll be reframing that rows and columns, okay, again, and I'll print the newest kind of rows and columns according to the data I needed. Okay. If it is in classifier, the random forest classifier, so instead of writing it Ella, now I'll be writing it as the RF. Okay. Priorly I've written it like what? Ella. Now I'll be writing it the RF. This is basically for the random forest. In the random forest, I'm gonna put, okay, not like this. Okay, go above and not like that. Random n estimators I've given us a 200. So this is model with 200 trees. What is an n estimator 200? That means model with the 200 trees are being there. In a forest, there is like thousands, okay, or hundreds of like the trees are being planted. Correct? I don't think so. Like, okay, even though you also don't know, right? Okay, or you also don't even consider it out in the thousands of like, okay, trees. How would you say that, okay, this is the tree sampled for the apple, banana, and mango, cherries, okay, whatever the fruits you have, right? Okay, grapes and all. How would you resemble it on a very early stage? So there is a batches being there. I don't know whether you have noticed or not. Okay, in your sort of colleges also, in your sort of like okay companies, okay, where you're working and all. I would say colleges itself. There is a every uh, steel type of badges being there, okay, attached to that particular tree, and there is a scanner, okay, that you scan, okay, that particular QR code, and you will get everything that has been stored. Every tree details has been stored into that kind of a scanner with the recognition as well as classification of it, that this tree belongs to this kind of I would say plant sapling breeds, okay, or this is somewhat like that, okay. So this is according to it. And if you also see like okay, if you switch on your camera and click any kind of like okay leaf or tree image, okay, it will show you how correct this tree is being there, is this tree is being suffering from so and so kind of a disease or not, right? So that depends upon you, right? Okay, how exactly it will be just trying to recognize it, right? Okay, but it does not mean like okay your code is wrong. It means like okay, before you go with the model building, you need to adapt with like okay, tomorrow you will see that okay, day 4, that we have the code for model optimization. The code n estimator is equals to number of decision tree model is equals to 200. Yes, so what is this basically is this n estimator is there, that there is into the model with 200 trees are being there, the classification is being allocated with it, and it will just try to fit, it will just try to fit with the optimization of the forest of the training data, correct? It will just get it, okay, optimization of it, okay. You don't know, okay, or you might know not like okay, start with accuracy based on to the simplicity you wanted to write it, but it could also just start with the scaling property, right? Okay, similarly to that, okay, you will just start with xg boost, okay, that is known as the xg boost and all. And with the xg boost, remember, um, extreme gradient boosting, right? Classifier, okay. And when you go with that, you have now the method of that is basically random state, which you know it pretty good way. You have the n estimators, that's 200, but in the xg boost you have a method that is known as the classifier of eval matrix, m log loss, right? M log loss. Now what is the xg boost? You know that it's in library, very efficient for the accuracy of boosting algorithms, right? And what is an eval matrix is equals to m log loss. It will set the evaluation matrix during the training. Now I'll ask you, let's say you visited some sort of uh, I would say your college itself or your companies and everything, right? Okay, you are being said like okay that you need to participate in this and this, okay, or sort of this and this kind of event, okay. You will say like okay, no no no, I don't think so, I'm like eligible to go with it, okay, I don't think so I would be able to do it and so, right? Okay, you will take your steps back, okay, you will definitely going to take your steps back, okay. And when the moment you will take your steps back, okay, you will be able to see that okay, which model fits onto the training data, right? Okay, it prints like okay the accuracy onto the test data. So eval matrix is equals to m log loss is going to be according to what the losses you are going to bear at, right? It often gives you the best performances of the three model, but does not matter. See, all of these three models, okay, you will see the accuracy is being different. Sometimes it gives you the very different kind of an accuracy, and sometimes it just give you the probability of like okay what you are writing it, right? Okay, and how exactly you are just trying to write it, okay. I don't think so like okay it would be just normal to say, but it is definitely the companionship is being there, right? Okay, that how you relate it, right? So it is being there and you can compare. Now I can tell you verbally because do have overall kind of codes only. Okay, I do have like, okay, the overall kind of codes and everything, so I can tell you that okay, what is going to be the accuracy score of this and that. So this will come most probably like 72%. Okay, this can come about like 85%, and the highest we generally used to get it for the XG boost, that's 87% of it, right? Okay, so 87% is the highest of it, and you need to just make sure like okay, the virtualization is being more, right? Any questions to anyone? Let me know. You will get this day 3 also. I'm just giving to you the again the link of this. Okay, so that you don't miss it out. Okay, just a minute. Uh-oh. Actually, what happened is, okay, let me just share it with you again. Okay, so here is the link. Again, yes, I'm giving you the attendance sheet also. Give me a minute. Okay, so if you see, here we go with your attendance sheet. If you have any questions, let me know. I'm all open for your questions then. Why I'm not able to give it to you? If you see this form, if you see this form, this is for the attendance sheet, okay, which is already being given to you, and I've just pinned into your chat section. Let me know any questions, any doubts. Okay, do you have? Okay, I can clear your doubts, no problem. Okay, I can clear your doubts, not a problem. Come on, everyone. Come on, guys. Let me know any questions to anyone. Make sure tomorrow what we are gonna do it is we are being actually starting with that, how do we connect, okay, or I am going to put everything into some sort of a website or somewhat like that, the deployments and everything. We will also do the deployments, but tomorrow we have model optimizations and the predictions, okay, and day after tomorrow we will deploy to the Gradio. You will be able to see it everything with a Gradio, okay, every single thing you will be able to see it with a Gradio. The output, then everything you will be launching it also. I'll show you what is in Gradio. That's a live integration. Okay, predictions would be there and all, but tomorrow we will be just going with what is in hyper parameter tuning. Okay, what is like okay kind of a prediction outcome of the hypothetical matches, saving the best model outcome of it. Okay, optimizations and the predictions. So this is everything you will be just doing it tomorrow with the relations behind it. Okay, so whatever the relation behind it has been there already been going to get it consider. uh, it's all yours, right? If you have any questions, please drop your questions. Any questions are being there, you can definitely drop your questions. Oh, I don't think so. It's on Hotstar. Clone is not there. Just a minute. Okay. You can fill it. Okay, don't worry. You can fill it. Okay, we can rename it. Okay. You can fill. You can fill it into it only, right? Okay. I can just tell the team that it's some sort of that and all. They will fetch your details. Don't worry. They will fetch your detail links and everything. Okay. Okay, then thank you everyone. Take care. Bye bye. Have a nice day. Let's meet tomorrow then. Okay. We will just begin and you can fill your attendance okay into this only. Fill it okay over here. Don't worry. I'll inform the team. I'll inform the team. You can fill it okay over here. Or don't worry. I'll inform it. You can fill your detail links over here. Thank you guys. Have a good day. Bye bye. Yes, it is correct only. That does not matter. Thank you everyone. Take care. Bye bye. Have a nice day. Thanks a lot.